Good morning, ladies and gentlemen. Welcome to week 23 of your SAT Math Prep. This video is designed for those students who missed their session this week for the regular sophomore Algebra 1 SAT Prep group so that they can still complete the quizzes assignment and earn their class credit. This could also be watched for those of you that are making or still need to finish your assignment and need a refresher before you do so. So this is our last week on the topic of factoring and equivalent expressions, solving by factoring and equivalent expressions. Again, make sure your name gets on this paper. You insert your teacher name in your class so that if you lose these guided notes, you can have them returned to you. You're allowed to use these on the quizzes, so it is very worthwhile to take good notes here. So the first example is something similar that we've been doing for several weeks now. Says when the given expression below is rewritten in the form A times the quantity x plus b times the quantity x plus c, where A, B, it should say, and C are constants, and C is greater than B, what is the value of A plus B? So the form that we're trying to put this into, A times x plus B times x plus C, would indicate that this expression has a GCF, a greatest common factor. All three of these terms are divisible by 3. So our first step would be to factor out the 3, which would divide each term by 3, resulting in 3 times the quantity x squared minus 2x minus 8. At that point, we're looking at basic trinomial factoring. We need to find the two numbers that multiply to negative 8 and add to negative 2. Now, in order for those numbers to multiply to negative 8, one of them will be positive and the other will be negative. Since they need to add to a negative number, the larger of the two numbers will be the one that is negative. The numbers that multiply to negative 8 and add to negative 2 would be negative 4 and positive 2. Those would be the numbers that go in the parentheses. Now, it does say that C is greater than B. So when we're looking at those two numbers, negative 4 and 2, 2 is greater than negative 4, which would mean that C is 2, B is negative 4, and the GCF, A, is 3. So then we need to actually remember that with the SAT, we're generally not going to have our answer right away. So we have to answer the question that's actually asked, which is what is the value of A plus B? Well, A is 3, B is negative 4. So we're doing 3 plus negative 4, which would be negative 1. Answer is A, negative 1. On example 2, it says solutions to the equation shown are A and B, where A and B are constants. What is the value of A plus B? So we should recognize, based on the x squared in this problem, that this is a quadratic equation. When we solve a quadratic equation, we do have several options for the method, but the easiest method is by factoring. So if we want to solve a quadratic equation by factoring, the first thing we have to do is move all of the terms in the equation to one side. So we need to move that 30 to the left side of the equation using subtraction. That would generate x squared minus 7x minus 30 is equal to 0. It's written in descending order or standard form, whichever version your teacher is using. And it is a factorable trinomial. We're looking for a pair of numbers that multiplies to negative 30 and adds to negative 7. That would be negative 10 and positive 3. So when we factor our trinomial, we factor it into x minus 10 and x plus 3. From this point, what we have to recognize is that in order for those two factors to multiply together to equal 0, one of those two factors, either x minus 10 or x plus 3, has to equal 0 itself. So that takes our equation and breaks it into two separate linear equations, which we would then solve using our basic problem solving, basic solving equation skills that we've learned previously in our course. So our two solutions would be x equals 10 and x equals -3. Now those numbers represent your A and your B. And it does not matter which one you call A and which one you call B, because what we're being asked is to find the value of A plus B. So it wouldn't matter which one you named A and which one you named B, you would still be adding 10 and -3 together, which would be 7. The answer is C. Again, example 1 there is what we've been doing for several weeks, and example 2 is what we've done the last week or two of this SAT prep. So neither one of these should be difficult for us at this point. The third example in our notes, however, is a harder question, and I did that on purpose so that we would have an example of a harder question. So moving on to example 3, and again, if you need to hear that explanation again, it's a video. You can always just back it up. Example 3 is a similar question to example 2, except the level of difficulty has been taken up significantly. It says the solutions to the equation shown are A and B, where A and B are constants and A is greater than B. What is the value of 2 times A plus 3 times B? So we do need to solve this equation. Again, we see x squared in there. We should realize that this is a quadratic equation. So we need it to equal 0. We need to move everything to one side of the equation. In theory, it doesn't matter which side. However, if we keep the number in front of the x squared positive, that makes the factoring step easier. So we should be adding 4x squared to each side. And since we're trying to get it to equal 0, this means we would also be subtracting 20x from each side. So that would give us 6x squared minus 13x plus 6 equals 0. So then we would look for a GCF. However, 6 and 13 do not share any common factors other than 1, so there is no GCF, which means that this is the more advanced factoring. Here at Speedway, your teacher is teaching this to you as what is called Michigan M factoring. Basically, we're going to have to factor this trinomial by grouping. So we're looking for a pair of numbers that multiplies to 36, which is 6 times 6 is 36. And we want those numbers to add to -13, which means both numbers are negative, -9 and -4. So what happens is we bring the 6x squared down, then we break the -13x into those two numbers, -9x, -4x, and then we bring the positive 6 down. This still equals 0, although at this point we're kind of ignoring that. We're not going to be doing anything with the equals 0 until we're done factoring. So what we've done is we've turned our trinomial into a 4-term polynomial, which allows us to factor it by grouping. Now, one of the big challenges is, remember that if your third term is negative, like this 4, you have to include that negative in the second group. Now we're going to factor out GCF. So from the first group, 6x squared minus 9x, our GCF would be 3x. So we factor out a 3x, which means we divide each term by 3x. That results in 2x minus 3 still being in parentheses. In the second set of parentheses, the GCF is 2. However, we want what's left in the parentheses to match what's in the parentheses for our first group, which means instead of 2, we need to take out -2 to change the signs and make it match, so that 2x minus 3 will be in both sets of parentheses. That still equals 0. So then we have our factors, because our factors are what is inside the parentheses, 2x minus 3, and what is sitting in front of the parentheses, 3x minus 2. Now what this means is, again, one of those two factors has to equal 0. So either 2x minus 3 equals 0, or 3x minus 2 equals 0. It has to be one of those two. So in each case, we can solve those equations, but they're not as easy as they were before. These are now two-step equations, which is another way that this is a harder problem, is that our answers actually end up being fractions, and you do need to leave them as fractions. Do not change them into decimals. You can get away with the first one, but not the second one, because the second one is not a nice decimal. Well, I mean, it's not really that bad. It's a repeating decimal. So if you were to round that off, you would actually end up messing up the problem. So our two answers are 3/2 and 2/3. Now in the directions, they told us that A was greater than B. So we have to ask ourselves which number is bigger, 3/2 or 2/3. Well, 3/2 is 1.5, whereas 2/3 is 0.6 repeating. So 3/2 is larger than 2/3, telling us that A is 3/2 and B is 2/3. Now that we know that information, we are able to answer the question. What is the value of 2 times A plus 3 times B? So 2 times A, which is 3/2, plus 3 times B, which is 2/3. Now you can feed that into your calculator, but you shouldn't really need a calculator for this, because when we do 2 times 3/2, the 2's cancel each other out and leave us with just 3. And when we do 3 times 2/3, the same thing happens. The 3's cancel each other out and leave us with just 2. So that really says 3 plus 2, which means the correct answer is C, 5. All right, folks, at this point, we're going to head over to Google Classroom. There is a link there for Quiz Is. And folks, if you're making this up and you don't get it done before the end of the week for 15 on Friday, I don't remember which one it's set to, the game will say, then you will need to use the makeup link, which will be posted with this video Friday at the cutoff. So you will have a separate game to play. But that's okay. As long as you get it done, your grade will count. Okay? So thank you very much for your time and attention. I'm going to briefly put up the Google Classroom code, and then this video will end. There it is, folks. The Google Classroom code for the sophomores, which is the group video that I'm doing right now, is Q7ULRP5. Thank you very much for your time and attention.